Okay, so again we want to find the equation of a hyperbola. Here's the information provided this time. We have a foci and it tells us what the asymptote is going to be. Alright, so let's first start by plotting the foci. That's 0 plus or minus 2. That's going to tell us a couple things. It's going to tell us that the hyperbola opens up and down, okay, because all this is going vertically there. We also know the center. The center is going to have to be exactly halfway between the two foci. So now I know that my center is going to be 0, 0. I also know that the distance from the center to the foci, that's going to be c. So actually I know that my c value should be equal to 2. So that's all the information that was provided from the first thing. Now, I don't have any other information provided here. I don't know my A and I don't know my B. Alright? We need to know that because when we look at the formula, this is the formula that we're going to use for our base formula. This is the one for a hyperbola centered at 0, 0 that opens up and down. That's the particular formula that we're going to use. That's our base formula that eventually we're going to plug our answers into. But we have to know A and B. In this case, I only know C. I have to know at least one of the other numbers. So like the previous examples I did, if I know either A or B, then I can solve for the other one. Alright, so in this case, I need to actually look at the asymptote. Now, the asymptote, let's look at the basic formula. If I have a hyperbola that opens up and down, here's the general formula for the asymptote. It's y equals plus or minus a over b times x. So, in this case, I'm particularly looking at just the positive version here. So I'm looking at y equals a over b x. The number that comes in front of that x is going to be a 1 there. So what I can extrapolate from this information is I can say that a over b, that's going to have to equal 1. Because this slope here has to match the slope over there in this particular formula. So now that I know this, that's going to tell me something. What that tells me is if I cross multiply both sides by b, I end up that a is going to have to equal b. That's what I get out of this particular case. So a equals b. Well, let's take a look at our formula for the c. That's a squared plus b squared. Now I do have some information. I know that c is equal to 2, so I can put that in. Well, let's take a look at this. Now, I need to figure out either solve for a or b, because then once I solve for either one of those, I know they're both equal to each other. What I'm going to do is I'm going to make a substitution here. I have a squared plus, now instead of the b squared here, instead of b, I'm going to replace the b with a because they're both equal to each other. So again, this is going to be like a substitution. Now if I do that, I get a squared and I get a squared here. So by doing that substitution, now I have only one variable. So now I can go ahead and solve this. 2 equals the square root of 2a squared. These are common terms. I can add them together. If I square both sides, I get 4 equals 2a squared. Just squaring both sides to get rid of the radical. This 2 is not going to be squared. I'm only getting rid of the radical on that side. And if I divide both sides by 2, I get that a squared is equal to 2. Okay, well, if a squared is equal to 2, I know that b squared is also equal to 2. So I get both of them together. So a squared is 2 and b squared is equal to 2. So now, when I come over here to my formula, I can just put a 2 in for a squared and for b squared. So this in the box is going to be my equation that I'm going to use here. So again, I use the fact that a equals b. All that came from my asymptote. I made a substitution here. I solve for a squared, and I know that I have this one, but then also I know that this one's going to be true as well. The reason why, if a is equal to b, that means a squared is going to be equal to b squared as well. So they're also equal to the same thing. So I know all that's going to be equal to 2. I put both those in there. So what you have inside the box, that's going to be your final answer. That would be the equation for the hyperbola that has this particular characteristics.